Hello everyone. In this lecture, I am going to show you how to calculate the position of center of mass of a continuous mass distribution. In previous lecture, I showed you how to calculate for a discrete mass system. In this, I am considering a continuous mass distribution. So the definition of center of mass for a continuous mass distribution is given by R center of mass is equal to summation over R bar into dm divided by summation over dm. If the mass distribution is uniform, then dm will be simply total mass of the body only. So this in turn we can write it as R center of mass is equal to, for a uniform mass distribution, dm can be written as total mass of the body only, capital M into summation over R bar into dm. So while calculating, we need to define three parameters which shows how the mass is distributed. That is, for a one-dimensional body, I call it as lambda. The distribution of mass is represented by a function lambda, which we call it as mass per unit length, dm divided by dl. For a two-dimensional body, we define sigma, how mass is distributed with area, dm divided by dA, where A is called area element, L is called length element. And for a three-dimensional body, I am defining one parameter which is called rho, dm divided by dV. So depending on the configuration that is given, one dimension, two dimension, or three dimension, we will use these parameters. Okay, as an example of this, I am considering this case problem number 1, in which I wanted to calculate the center of mass of a rod of length L. So for this purpose, here I am considering a uniform rod of length L, and its mass I am considering it as capital M. For this purpose, first what we should do, first you should fix the reference where you wanted to fix. You can fix exactly at the center or at right hand or left hand. I am considering here this as the origin. This horizontal direction I am taking as x-axis. This vertical direction I am taking it as y-axis. Now I am calculating the center of mass for this mass distribution. Here it is uniform mass distribution. So for that purpose, what you should do is, from this origin at a distance, let me call it as x, we should consider a small strip of mass dm. For a continuous mass distribution, first we should consider a small elemental mass. So for this elemental mass, from the definition of center of mass, R center of mass is given by what you can write, summation over the distance r dm. What is r? Distance of dm from the reference. So this is my reference. From this reference, distance of dm is x into mass is dm divided by, it is a uniform mass distribution because of which integral over dm will yield you total mass of the rod m only. And the value of integration. So all these dm's you should keep on adding from x is equal to 0 to x is equal to L, because of which limit of integration is x is equal to 0 to L. Okay, next, it is a linear distribution. That is, mass is distributed along the length only. This is one-dimensional body. So because of which the parameter that is useful here is lambda. But here dl I wrote, here element that I considered, the strip of the length of the strip that I considered is dx only. So I am replacing dl with dx. So this we can write it as, that is equal to summation over 0 to L x into, what is dm? Dm is equal to lambda into the length element under the consideration. Thickness of the length element is dx only, dx divided by m we can write. Okay, so here lambda is constant because it is uniform mass distribution. If it is non-uniform mass distribution, he will give the function of lambda. But here I am, simplicity's sake, I am considering is uniform mass distribution only. So because of which you can write it as lambda is constant. You can pull it outside the integration. Lambda divided by capital M into summation over 0 to L x dx. So integration of x is x square divided by 2. So if I substitute that, therefore R center of mass is equal to what I'm going to get here is lambda divided by m into x square divided by 2 between the limits 0 to m. So if you substitute, what is lambda? Let me write it lambda only into this will become L square divided by 2. What is lambda? Dm by dl. If you integrate it, total mass divided by total length only. So m divided by L divided by capital M into L square divided by 2. So here L gets cancelled, mm gets cancelled. What you're going to get here is L divided by 2. So center of mass of uniform rod is located exactly at its geometric center. Simple thing. For a continuous mass distribution, what happens? If the mass distribution is uniform, okay, center of mass is located exactly at the center, geometric center only. So by using the symmetry argument also, I can say that its center of mass will be exactly at the center. In a similar way, if you take a circular ring or circular disc or a sphere, hollow sphere or solid sphere, so its geometric center is exactly at the center only. So the coordinates of center of mass for a ring or a sphere or a disc, whatever you consider, exactly its center, that is it is at its center only center of mass is located. If you take a square plate or a rectangular plate, for all these by symmetry argument, what you can say is center of mass is located exactly at the center only. And do remember, if at all distribution of mass is uniform, if the distribution of mass is non-uniform, things will change depending on how the mass is distributed. So for this purpose, what I'm going to do here is, as a second situation, I am considering a small arc of length L and mass M. Or else, instead of taking length, what I will do is, I'm considering a small arc which is subtending an angle theta at the center of the circle. This is theta. And the radius of this arc is r. So for this element, I wanted to calculate what is the location of center of mass. Okay. So here what I'm doing is, I'm assuming that it is symmetric about x-axis. I'm assuming that it is symmetric with respect to x-axis. Okay. So in this situation also, simple thing, what I will do is, I will consider a small elemental strip. Here I will consider a small elemental strip at an angle theta with respect to this symmetric axis. At an angle theta, I will consider a small elemental strip of, let me call this length is dl, which is subtending an angle d theta at the center. Okay, so first I will write down the expression for what is the location of center of mass for this elemental strip. Okay, so out of symmetry, as I told you, it is symmetric about the x-axis. It is symmetric about the x-axis, because of which the center of mass should lie on the x-axis only, because of which y center of mass is 0. Y coordinate of center of mass is 0 because it is lying on the x-axis. Now I should calculate x center of mass. For that purpose, I should consider what is the distance of this element of mass dm from the origin. So that means this distance I should calculate. This distance from here to here. This distance I should calculate. If you take this as r and this angle as theta, component of r along the horizontal direction, the distance will be how much? R cos theta. So the x coordinate of this elemental strip dl is given by r cos theta. So if I come back to this expression, therefore x center of mass is equal, because y center of mass is 0, is equal summation over the x coordinate of center of mass is how much? R cos theta into what is the element that I considered here? Length of the element is mass of the element is dm only, dm divided by, let me call total mass is capital M, because it is uniform mass distribution. Okay, now therefore in this r is constant, you can pull it outside, or else first I will define what is dm. Dm is what? It is one dimension. This is length only length, there is no area. So because of which I can use lambda. What is lambda? Dm by dl. Therefore dm is equal to what you can write? Dm is lambda dl here. So if you look at this expression, what is the relationship between dl, r and d theta in a circle? dl is equal to r d theta. That implies dm is equal to what you can write? Lambda into, in the place of dl, what you can write? R d theta. This I am going to substitute back into this expression. Therefore, x center of mass is equal to what you're going to get here? Sum 1 divided by capital M into summation over r cos theta into what is dm? Lambda r d theta. So r into r is r square. So as the integration is with respect to theta, I can pull this lambda and r square outside. Lambda r square divided by capital M into summation over cos theta into theta. Here the problem comes with limit of integration. What is the limit of integration? As I said, it is symmetric about the x-axis. Above x-axis half, below x-axis half. Total angle is theta, means above x-axis means 0 to theta by 2. 0 to theta by 2. Like that, I should perform the integration above the x-axis and below the x-axis, and it is symmetric function, because of which you can multiply it by 2. So 2 into 0 to theta by 2. Okay, so that is equal to what you're going to get? 2 lambda r square divided by capital M into integration of cos theta is sin theta between the limits 0 to theta by 2. That is equal to 2 divided by capital M into r square into what is the lambda? Lambda is mass per unit length. Total mass divided by total length of the sector. Length of the sector is equal to L is equal to what you can write? R into total angle subtended, r theta into, if you substitute upper limit, it will become sin theta by 2. Lower limit, anyhow, it is 0 only. That is equal to m gets cancelled, r gets cancelled, because of which you will be getting 2r divided by theta into sin theta by 2. So here, therefore, coordinate of x center of mass is given by, for this strip of length L, which is subtending angle theta at the center of the circle, x coordinate of center of mass is given by 2r divided by theta into sin theta by 2. Be careful, while using this expression, this theta should be substituted in radians. You should not substitute in degrees. You should, if it is given theta is 90 degrees, you should be written it as pi divided by 2, not as 90. So theta should be substituted in radians. As an application of this, I am going to extend this for a, what you call it as semicircular ring. That is, for example, it is in semicircular shape. For this semicircular shape, what is the location of center of mass? Because it is symmetric about this x-axis. This I am taking it as y-axis. When it is symmetric about x-axis, y coordinate of center of mass is 0. Y center of mass is 0, obviously. Now I should calculate what is the x coordinate of center of mass. That is somewhere over here, it's the center of mass is located. So to calculate x center of mass, what I will do is, I will use this expression. What is that? 2r into sin theta divided by 2 divided by theta. Therefore, x center of mass is equal to what you can write? 2r divided by, for a circle, for a semicircle, the value of theta changes from, for this arc, the total angle is theta. For this half of the circle, semicircle, the total value, theta value should change from 0 to pi. That only I am substituting. So theta is equal to how much you will be getting here? Pi into sine of theta is equal to pi. Pi divided by 2. That is equal to what you will be getting? 2r divided by pi, because sine pi by 2 value is 1. Therefore, x center of mass is equal to 2r divided by pi. So by using this simple expression, you can calculate for semicircle or quarter circle or 3/4 of the circle. As an example, you take it, this is x-axis and this is y-axis. What is the location of center of mass for this quarter circle, 1/4 of the circle, if I ask you? So here, this is symmetric neither about x-axis nor about y-axis. Am I right? So what I will do is, I will consider a symmetric axis like this. This is my symmetric axis. Okay, this is symmetric axis. I am naming it as some x dash axis. So the center of mass should lie on this x dash axis only, and I will use this expression. Therefore, x dash center of mass is equal to what I can write? 2r divided by, what is this total angle from here to here? It is pi by 2 into sine of pi divided by 4. That is equal to how much you're going to get here? That is equal 2 to the 4r divided by pi into sine pi by 4. Sine 45 is 1 by root 2. 1 divided by root 2. This you can write it as 2 root 2, because 4 you can write it as 2 to the 2 into root 2 you can write it 2 root 2 r divided by pi is x dash of center of mass. So I calculated x dash, but I need answer in terms of x and y. So this is somewhere over here. Then its x coordinate is given by, this is symmetric axis, because of which this angle is how much? You will be getting pi divided by 4. X dash cos 45. Therefore, x center of mass is given by, x center of mass is equal to what you can get it? X dash cos 45. X dash cos pi divided by 4. That is equal to, x dash is equal to how much we got? 2 root 2 r divided by pi into cos 45 value is again 1 by root 2. So root 2 gets cancelled. You will be getting 2r divided by pi. So x dash value, x center of mass that you're going to get here is 2r divided by 5. Similarly, we can calculate y center of mass also. Y center of mass is equal x dash sine pi by 4. That is equal to this value also you will be getting 2r divided by pi. So like this, by using this expression, we can calculate for any circular strip, you can calculate.